A laptop computer is purchased for $21.50. After each year, the resale value decreases by 35%. What will be the resale value after 3 years? So this is going to be y equals 2150 times, how do we drop 35%? 0.65. We multiply by 0.65. The way I like to think about that is, how much do you get to keep? If you lose 35%, then you keep 65%. And then we just plug that in to get our answer. Okay, that's easy enough. At the beginning of a population study, a city has 360,000 people each year. The population has grown by 5.9%. Are they going to use, I'm not sure if they're going to use PERT or not. No, they're not. Okay, so 360,000 times 1.059. Oh, that's just the function right there. That's the equation. Any questions? Okay. Okay. A biologist has 694 grams of a radioactive substance. Find the mass of the sample after 3 hours if it decreases according to a continuous exponential decay model. So this is PERT. P-E to the RT. So 694 E to the 0.06 times 3. So we have this much to start with. That is our rate of increase. Oh no, this is a decrease, sorry. Negative 0.06 times 3. Okay, any questions there? Plug that into your calculator to get the answer. And so here we have an equation. Mary places a bottle of water inside a cooler. As the water cools, degrees Celsius is given by the following function, where T is the number of minutes since the bottle was placed in the cooler. Mary wants to drink the water when it reaches 17 degrees Celsius. That's kind of random, right? How many minutes should she leave it in the cooler? So, when this is 17, I need to solve for T. And we can't use logs until we get the E by itself. So I need to subtract 9. And we have 8 equals 13e to the negative 0.03t. Can I ln at this stage? Or I guess I could, but should I ln at this stage? No, I need to get rid of the 13. So we divide by 13. 8/13 is e to the negative 0.03t. ln both sides. Drop that. The ln of 8/13 is equal to negative 0.03t ln of e, and the ln of e is just 1. So we divide this by negative 0.03. Oh, let's do this. So the ln of 8/13 divided by negative 0.03, 16 minutes. Well, 16.18 minutes. She can pull it out of the cooler and drink it when it's 17 degrees. That's weird. Okay. So We have this many bacteria to start, and in 5 hours we reach that many bacteria. What is the hourly growth rate? So it tells us this is a continuous growth model. So y equals p times e to the RT. So 2135 is equal to 1900 e to the 5r. So we divide by 1900, ln both sides. On the left, we have the ln of 2135 over 1900. And that's equal to 5r ln e. And this is the reason why I always use the ln, well, one of them. ln is one fewer letters to write than log base 10. And anytime you have the ln of e, it just turns into a 1. So that is going to be my rate. So the ln of 213, what was it? 35 divided by 1900, and we'll divide that by 5, and I get a rate of 2.3%. So these bacteria are increasing at 2.3%. All right, last one. A certain substance decomposes according to a continuous exponential decay model. To begin an experiment, the initial amount of the substance is 500 kilograms. After 15 hours, 410 kilograms are left. So my formula is y equals 500 e to the 15r, and this would be 410. So I will divide by 500 and ln both sides. So we get the ln of 410 over 500 equals 15r ln e. So the ln of 410 over 500 divided by 15, we are dropping 1.3%. So this first one is y equals 500 e to the negative negative 0.013 t. Oh. So it wants the exact answer. So this goes there. So we're going to put 500 in here, and then r is that. The ln of 410 over 500 all divided by 15. Okay. How much of the substance is left 21 hours after the beginning of the experiment? So 500 e raised to the answer times 21 would be 378. And notice it will say do not round any intermediate computations. So notice that I used all of these decimals by typing in answer. Is there another piece to that, or is that everything? That's it. Get to work.